Have you ever stood inside an elevator, watching the numbers slowly change, and wondered, how does this metal box actually move us from one floor to another? We trust elevators every single day. At malls, offices, or apartments, we step inside without thinking twice. But behind that smooth ride, there's an incredible system of physics, engineering, and design that works perfectly in sync to lift us through the air. In this video, we're diving deep into how elevators actually work, from their surprisingly dramatic origins to the cutting-edge tech that powers the tallest buildings in the world. So, hold on tight, because we're going to travel down to the heart of the elevator's secret world. Humans have always wanted to go higher, but before elevators, going up was exhausting. Imagine carrying heavy stuff up 10 floors using stairs. No thanks. Ancient civilizations like the Egyptians and Romans used ropes, pulleys, and even animals to lift things. But these were more like cargo lifts, not for people. It wasn't until the 1800s that engineers started building real, human-sized elevators. Here's the problem. People were terrified of falling. Back then, elevators were basically wooden platforms tied to a rope. If the rope snapped, you'd fall. That all changed in the year 1852. A man named Elisha Otis invented the first safety brake system. To prove it worked, he stood on a lift platform at a big New York fair and had the rope cut in front of everyone. The platform didn't fall. The crowd went wild. Otis's invention made elevators safe, and it changed the world forever. By the late 1850s, the first passenger elevator opened in a luxury hotel in New York City. From that point on, cities started growing up, not out. All right, so how does an elevator actually move? Let's break it down simply. Think of it like a seesaw. On one side, you have the elevator cabin, the box where people stand. On the other side, there's a heavy weight called the counterweight. They're connected by strong steel cables that run over a big pulley at the top. When the motor pulls one side up, the other side goes down. It's perfectly balanced, so the motor doesn't need to use crazy amounts of power. Inside the shaft, there's also a brake system, a strong electromagnetic lock that automatically holds the elevator in place if power goes out or something fails. It's one of the many reasons elevators are incredibly safe. And then you've got sensors, lots of them. They tell the system exactly where the cabin is, how fast it's moving, and when it needs to slow down. That's why the elevator always stops perfectly aligned with the floor. So yeah, the next time you ride one, remember, it's not magic. It's physics, balance, and a lot of clever engineering. In the beginning, elevators were powered by steam engines. They were slow, noisy, and honestly kind of scary. Then, in the late 1800s, electric motors came in and changed everything. Early electric elevators still needed an operator, someone who pulled a lever to control speed and direction. But by the mid-20th century, buttons replaced humans. Automatic systems could detect when to stop and start on their own. Today's elevators are like computers. They talk to each other through a central control system. If 10 people in a building press the call button, the system calculates which elevator can respond fastest. It's all about efficiency. And the future? Well, companies are now developing ropeless elevators. They move not only up and down, but also sideways. Imagine a lift that can slide across a building like a train in the sky. That's real. It's called the Multi-System by ThyssenKrupp. Let's clear something up. If an elevator cable snaps, it won't fall like in the movies. Modern elevators use several cables, each one strong enough to hold the cabin alone. If one breaks, the rest still hold perfectly fine. And at the bottom of every elevator shaft, there's a shock-absorbing system, like giant springs, to soften any emergency landing. Here's a wild fact. Riding an elevator is statistically safer than driving a car or even taking the stairs. Yep, stairs cause more injuries each year than elevators ever do. Still, people do weird things inside lifts, like blocking the doors with their hands. Bad idea. It can mess up the sensors. Or pressing all the floor buttons for fun. That just slows everything down. So next time, let the elevator do its thing. It's way smarter than you think. Without elevators, skyscrapers wouldn't exist. period. Think about it. Before elevators, the higher floors were the cheapest places to live because no one wanted to climb the stairs. Now, thanks to elevators, the top floors are the most expensive. The view sells. Elevators made vertical living possible. They connected offices, homes, malls, and restaurants in ways that redefined how we design cities. Architects literally plan buildings around elevator systems. If you put too few, people get frustrated. If you put too many, you waste valuable space. So there's a science behind elevator count and placement. And beyond the tech, elevators changed how people interact. Those short, silent rides with strangers. That awkward nod, that quick glance. That's part of modern city life now. So what's next? We're heading into an era of smarter, greener, and even cooler elevators. Imagine stepping into a lift that knows who you are. It recognizes your face and takes you straight to your floor. No button pressing needed. Or a lift that moves silently using magnetic levitation, just like bullet trains in Japan. Some companies are even experimenting with glass elevators that give you a 360-degree virtual view while you ride. So instead of staring at the floor numbers, you could be looking at a digital city skyline. The elevator is no longer just a tool, it's becoming an experience. And in a world that's constantly reaching for the sky, this simple vertical box will always be the heart of the climb. Every time you step inside an elevator, you're stepping into over 150 years of innovation, trust, and brilliant engineering. It's not just a machine, it's a symbol of how far we've come. If you enjoyed this kind of content, hit that subscribe button, leave a like, and share this video with someone who loves learning how things work. So far, we've talked about how elevators were invented, how they move, and why they're safe. But the real magic, the part most people never see, is what happens behind the walls. Every time you press that silver button and hear the familiar ding, a small orchestra of mechanical parts and computer systems wakes up. And they all work together with one purpose, to get you from point A to point B safely, smoothly, and quietly. Let's go where the public never goes, inside the machine room. Picture a small, dimly lit room at the top of a building. This is the elevator's brain. Here you'll find the control panel, the motor, and the massive pulley wheels that move the elevator cables. The control system is like the elevator's nervous system. It receives signals from every button you press, every door sensor, and every floor indicator. Then it calculates what to do next. It decides which elevator should respond first, how fast to accelerate, and when to slow down for a smooth stop. Modern elevators even use algorithms to predict where people are likely to go. If most passengers at 9 a.m. go to the office floors, the system automatically sends more elevators to the lobby. That's why in busy buildings, you almost never have to wait long. And here's something few people know. Many elevators today are connected to the internet. They send data about usage, temperature, and motor condition to engineers who monitor them remotely. That means if a lift starts acting weird, someone can fix it before it breaks. This is called predictive maintenance, and it's a big deal. It's the reason modern skyscrapers can run dozens of elevators with almost zero downtime. Now, let's talk about what actually moves the elevator, the motor and the drive system. In most buildings, there are two main types, traction elevators and hydraulic elevators. Traction elevators use steel ropes and a counterweight, like we discussed earlier. They're perfect for tall buildings because they're fast and energy efficient. Hydraulic elevators, on the other hand, use a piston that pushes the cabin from below using fluid pressure. They're slower, but they don't need counterweights or rooftop machinery, making them ideal for low-rise buildings and malls. But both systems share one key idea: control. When you move from one floor to another, the motor gradually speeds up, cruises, then gently slows down before stopping. You rarely feel the acceleration, but it's happening constantly, managed by a frequency converter that adjusts motor speed in microseconds. It's kind of like cruise control in a car, but far more precise. Because even a tiny miscalculation could cause a sudden jolt or uneven landing at a floor. And when power goes out, don't worry. Every elevator has a backup brake system powered by springs and electromagnets. If electricity cuts off, the magnets release the brake slowly, and the elevator stops safely in place. That's why you'll never see an elevator freefall, no matter how dramatic the movies make it look. Let's give credit where it's due, to the parts that work non-stop but rarely get attention. The wire cables are made from twisted steel strands, each thinner than your finger, but together they can lift tons. A typical elevator cable can support about 10 times the cabin's weight. That means even if one cable snapped, the rest would easily hold. Next, the bind braking system. This is the unsung hero. Every elevator has a set of clamps on the rails that automatically engage when there's a problem, like loss of power or overspeed. They grip the rails instantly, stopping the elevator safely in just a few inches. Then there are the kite doors, which are way smarter than they look. Sensors line the edges to detect motion, temperature, or even airflow changes. If someone walks too close, the doors reopen automatically. But here's a fun fact. In high-end elevators, the door's movement speed is calculated based on how many people are inside the cabin. More people mean slower door speed to avoid accidents. All these small details come together to create an experience that feels effortless, but is actually a masterpiece of precision. You might not realize it, but every sound and vibration inside a lift is carefully engineered. That ding sound when the doors open? It's tuned to a specific frequency that's easy for humans to recognize, even in noisy environments. The floor indicators light up with the same brightness levels used in aircraft cockpits. Bright enough to see, but not enough to hurt your eyes. And the floor texture inside the cabin? It's designed to reduce static and prevent slipping. Some luxury elevators even play soft background music, because studies show calm sounds reduce the feeling of claustrophobia in small spaces. It's fascinating. What we often think of as a machine ride is actually a carefully designed human experience. The next generation of elevators is being built around artificial intelligence and energy efficiency. Imagine this. You walk into your office building, and before you press anything, the elevator already knows which floor you work on. It's connected to your company ID or smartphone. The cabin arrives with your name on a small display. Good morning, Alex. Heading to floor 27? AI systems will also learn from traffic patterns, like when lunch hours are busy, and adjust operations automatically to handle crowds faster. Then there's the rise of green elevators. Some modern lifts can generate electricity as they go down by turning the motor into a small generator. That energy goes back into the building's power grid. It's like a Tesla regen brake, but vertical. These innovations show one thing: the elevator is not done evolving. It's becoming smarter, safer, and more human-friendly every year. Every time those doors open with a soft ding, remember, you're stepping into one of the most advanced machines ever built. Something that has quietly lifted humanity, both literally and metaphorically, for more than 150 years. If you enjoy stories like this, hit that subscribe button, leave a like, and share this with a friend who loves learning how things really work.